Hello guys, my name is Joe Vargas and I'm going to show you our statics presentation. So before I get started, what is statics? Statics is all the forces in equilibrium and they equal zero, and we can have all kinds of stuff like free body 2D objects, 3D objects. They're in all kinds of different shapes and forms and ways. In our case we have a 2D object with tensions and lengths and two different angles. So how we started it was this is our algorithm. So we wanted to define the problem labels in known variables, and then we want to draw our free body diagrams, set up linear equations in statics. This is the definition of statics. Then we're going to create an Excel sheet like it says, and then check values if they're positive, change them to negatives, and all the other tasks, and then end, of course. So first of all, the free body diagrams, like it says. So we started off with three different free body diagrams. Of course, the main free body diagram, another free body diagram with tensions and weight. This is the free body diagram in forces in equilibrium right here. And then free body diagram in lengths, so we can find LBC, which I'm going to later explain. So we start now with task 2. So first we need to create an Excel sheet. Our Excel sheet, and all the highlighted things are what's wrong with, or what's going to be changed, or what the code is supposed to change. So that's our Excel sheet in column 1, 2, 3, and so forth. So we need to first check that every value is positive, and if there's a negative number, human error should be replaced by the absolute value. So right here is negative 10, right? So I pull up MATLAB and I run the code, and let's say I say 2. Okay, so I say A. So right here, 10 is now changed to positive number right here. Okay, so that checks off that part of the task. Now we're going to say that we need to check that all values of LBA are less than D, meaning that D has to be greater than LBA, because of course if D is not greater than LBA, then this triangle is not true. So we go over here, and this is how we checked. First of all, this is how we checked for positive numbers. We say that if it's not equal, or if it's less than 0, then we're going to put the absolute value of it into that specific row and column, and we use the for loop so it can check every single row and column. Now to do the positive number, to check if LB is less than D, we're going to say that we're going to do another conditional and say that we're going to check the rows in 1 and then 2. 1 and 3, because that's D and LB, L of B, L of AB. So when we do that, we're going to say that we're going to do an fprintf statement, and it's going to spit out exactly what those numbers are that are wrong. So in our case, we see that 5 is greater than 4.5, 4 is greater than 6.5, and 10 is greater than 9.5, right? So now we go here and we run the code, and it should tell me that 4.5 is D equals, so we need to replace the number less than 4.05. So let's say I replace it bigger than that. It's going to keep spitting it out until I get the right value. So I plug this in, and then now the next value, which is 9.55, and that is true in our Excel sheet, which is right here. Oops, I'm sorry, I don't know why I had that highlighted. So in our spreadsheet, 10 is greater than 9.55. So we go back here and we say we can call it 7.5. So then that comes up. So then now it replaces the new values, right? On to the next task. Now we need to create the function, but we are given D, LAB, and LAC is actually LBC, not LAC, and W. We need to find LBC. So this is how we found LBC. We, first of all, we did Pythagorean theorem, so we said that like this right here. So since y equals y, of course, we can say that we can set y equal to each other to find LBC, but we need to know x because it varies. So we said in our script that x ranges from 1 to L of AB. The reason why we said that was because x cannot exceed LAB. If x exceeds LAB, then it's gonna look like this, and it's gonna be really funky, and it's not gonna be a true triangle. So it's gonna range from 1 to LAB, and that's why we did a for loop, so you can check every single number, every increment. So we did Pythagorean theorem, and then we set the y's equal to each other, and we found LBC. And if I move on to our function, which is right here also, we put it again in a for loop, and then we set e equals to d minus x. The reason why we did that so it's easier to input into MATLAB. I mean, we could have just put it in parentheses. So this was our finding of LBC. Now, whenever we do to find the theta, which is right here, we did law of cosine and sine on this free body diagram, and it was much easier to do it with LBC, the lengths, and it was much better to do it with x and d. So when we did that, we were able to find phi and theta, although we only needed to find theta because the problem said just find theta in both tensions. So we found theta using those, and the reason why we did a cosine was because it's arc cosine. That's the function, built-in function in MATLAB, and then we found phi. Now this t right here is minimum and maximum of LBC, because LBC, yes, can move from, it can be anything, because if LAB moves down here, then LBC can move. So both of them are moving different moving lengths. They can vary from any range, both of them, not just one of them. So we had to find the minimum, and we had to find the increments essentially to find phi. Now when we moved down to the tensions, which was much easier to find, we used the law of statics. So we set the forces in equilibrium of x and y. We were using this free body diagram. Now when we used this, we didn't need increments of x or whatever. We just needed our theta and phi. So as you can see, I found all the forces in x and all the forces in y, and then I solved for all of these. And then once we found TBC, we had TAB. So now we had to use all the forces in y and find TAB by itself. So we can plug this in. We can plug TAB back into BC. Now, once we find that, we use the trig identity, and we got sine of phi plus theta, and we found both of our tensions. So we plug those into MATLAB, and then we end our function. And now this is what's going to spit out, the tensions and theta, because that's what the task is asking for. So when we move on to the task 4, we need to plot everything. We need to plot both tensions respect to AC, which is BC. So now when I run this, or actually this is our plot, right? So when we plot, the reason why we use this line space right here was because it was to help to organize better, because then the graph would be all funky and look weird. And up here is when we found the maximum of length BC, which was in task 4 at the very end. It says solve for max LAC, which is really BC. So we found that using a for loop, so it can keep using the same numbers that we were using originally. Now we find, now we plotted everything, and now I can run the code to show y'all what it looks like. So this is what we get. This is our tensions. This is our tension respect to length, and we use the legend to see which tension is which, of course. And I believe that's it. Thank you.